Good afternoon, everyone. My name is Andrew Banson. Thank you for attending this webcast on the use of batters in advanced road design. In this session, I'll run through the use of batters from right from the fundamentals through to the more advanced. So if you haven't been introduced to commands such as intelligent sections before, then this should be a very useful session for you. Along the way, I will show you how you can resolve issues such as batter overlaps, and I will be giving you a sneak peek of Advanced Road Design version 16.1. In fact, the image that you're looking at right now on screen is a direct screenshot from the new version, which I will talk a little bit about later. This webcast has been recorded, so if you would like a copy, then please send an email to us at feedback@civilsurveysolutions.com.au. And in regards to questions that you might have throughout the session, please feel free to add them to the Q&A or chat windows, and I'll do my best to answer them. I may attend to these questions at the Rightio, so here's the agenda for today's session. As I said, I wanted to explain how batters work right from the fundamentals, and which a lot of you probably have a good grasp on already, but I thought I'd start there anyway. I'll show you how to create slope batters, fixed width batters. You may or may not have used dual leg batters before. I will run through some of the tools we have available in the design data form, and but as we progress through the session today, I want to show you more conditional based options, and for example, depending on certain depths, we may want to change the batter slope. We might want to add repeated benching if we're in large amounts of cut. You might want to add retaining walls, features like that, or you may even just want to set the batter to match to an alternate surface. So other than matching to the sampled surface, you might want to match to some sort of rock surface or lot grading surface. So I'll show you how you can do things like that as well. I get from users, and so I'll talk about this and reasons why batter overlaps occur, and what options we have to resolve them. So as I mentioned, next month we will be releasing our most exciting version of Advanced Road Design yet. You may have received news of this recently, but we have plenty of new tools in this version that will really change the way that you go about civil design. We've included a new command named Model Viewer. Your design will be displayed in a fully rendered 3D environment, but it's more than just that. As you make changes to the design, the 3D model dynamically updates. You can do analysis such as site distance checks. You can add cars, trees, and even run commands such as the vertical grading editor or design data form from it. You can output videos and much more. We also have a new cross-section plotting engine. It is that fast when you make changes to your section plots update. We've been working on this new cross-section engine for a while, and it's now ready for release. The engine includes awesome annotation tools as well. One of the biggest requests we get from users in regards to annotating up cross sections. There are new multi-user collaboration tools, so you can share your surface, road, or pipe data with other members of your team. We had something previously, but this is way better. These tools we've got now. This means that different colleagues can be working on different stages of a project, or someone might be working on the pipe design and someone else works on the road design. Or you could just use these tools to simply store large projects over multiple drawing files. Look, there are plenty of new features coming in this release. And because of this, because this is such a huge, exciting release, we are going on a national tour. We are putting on full-day events where you can get trained up on the new features and you can meet and chat with our team. And we'll be running through some interesting cases workbook along with some training videos as well. We haven't run one of these types of events in a long time, so it will be great for us to get back on the road and see you all face to face, and even get some feedback as well on the software and the new features. But anyway, you can book a seat at our website, advancedroaddesign.com.au. Okay, so look, before I open up the software, I wanted to quickly discuss the different types of batters available in ARD. As I said, you can apply slope and fixed width batters, dual leg batters, and for more conditional sections, you can use the intelligent sections command, which I'll get to towards the end of the session. So I'm sure everyone's familiar with how the slope batters and fixed width batters work, but let's just run through them anyway. So slope batter is our most basic batter. That allows you to set a slope for cut and fill. If you didn't know, you can actually set an alignment to control the maximum width of the batter. So if the batter was to extend past, say, a property boundary, you can nominate an alignment on the boundary and the software will not form the batter across it. But that will result in a steeper slope. You can create a fixed width batter. In order to do so, you set a fixed width out from the center line. The result is a varying slope, so you might end up with a batter slope that is a bit steep if you use this one, but you can control the width of the batter. Something similar to a fixed width batter is a batter that we have included that I'm not too sure whether too many people use, but it's worth showing you anyway. This is a dual leg batter. It's very similar to the fixed width batter, but if the slope is if the slope of the first leg back to the surface is too steep or outside a slope range, so you define a minimum and maximum slope range, and what happens is a second leg gets put in. Slope you pick. So rather than having the one slope, the one batter leg added to the surface, you'll get two if the initial slope is outside those ranges. So if you haven't seen that type of batter before, then I'll run through and show you. Okay, so I'm just going to share my screen. Okay, so hopefully you can all see my my screen. As I said, I'm running Civil 3D 2016 with a beta version of ARD 16.1. So the window I've got open now is actually the model viewer window that I talked about earlier on. So we think that this window will become as common as the design data form or the vertical grading editor or the cross-section window. I won't talk too much about it yet, but we will use it to demonstrate the edits we make to the roads. So I'll just leave it over here for now. To show batters on a very simple road, this is just a lawn street, and I'm sure you've all seen it before. If I open up the template editor, this is the template that I currently have added to DeLawn Street. I wanted to use a rural template today, and you'll see in the template I have some table drain codes on the left and to the right. Another thing I wanted to show you today was a method of controlling table drains and adding them and inserting them dependent on cut and fill. But I didn't want to use the table drains command in the design data form because that can be limiting. These table drains that I've added are driven by a string that I've created. So I'll show you that a little bit later on. So the first place to go in and add batters in the software, as I'm sure you are all aware, is via the template editor. And if I want batters on the left side, I click on this left side button, and the right side for the right side. When you do so, this dialog box will load up, and you've got three options here: no batters, slope batters, and fixed width from center line. Okay. If I didn't want to add batters to a road, I could select on this No Batters tab. However, ARD loves to insert batter codes. It likes that you've added the batter codes in LBAT and RBAT. And that's because it uses those batter codes to form its automated boundaries. And if those batter codes don't exist, then the automated boundaries don't form. So I do know of cases where, although you might click on no batters here, the software, when running AutoModel, might add them in. I will show you where you can permanently turn those batters off, so the software won't re-add them again for you later. But as I said, standard slope batters or fixed width batters can be added from this dialog box straight in the template. But in the design data form, we can edit those later on. So what I might do is I'll open up the design data form. One thing I want to show you model view is you can actually run commands from it. So rather than going to the design data form from the ribbon, I can click on design data form. I'll just make some space so we can run through some stuff. Now, in this particular job, I just wanted to point out I have a boundary alignment. The alignment's called boundary max offset, and if I select on that, you'll see the alignment in the drawing there. One thing I wanted to show you when I make some overrides for slope batters is to show you that we can nominate a maximum offset for the slope batters. So to override a batter, I select on the batter's entry and hit the button with the green plus to add one in. You'll see the list of different types of batters in here. Some of these have been in the software for quite a while. Some of them are even, I suppose, obsolete. The multi-section batters routine has been replaced with the intelligent sections command. So if I click on slope batters, what this variation or override allows me to do is override the batters over a certain chainage range. So in this case, I might say, look, from chainage 0 sides, I want to set the slope to be 1 in, we'll go 1 in 6. Now, the reason why we have start and end is because over a particular range, you might transition or set a transition length from one batter to the other. So we might want to merge from a 1 in 4 batter to a 1 in 6 batter, but I might want to do that over a particular chainage range. So what I could do is put in a transition region and say that at start chainage, I want to say 1 in 4, but by the time we get to the end, I want to be at, or the end change, I want to be at 1 in 6. And the software would do a linear transition over that region. If that isn't occurring with this variation, then you tick on constant slopes, which is defaulted here is ticked on. So if I select on add update, you can see that the batters have updated, and I'll just open up a cross section here. Let's just go across. Seems like 1 in 6 ain't finding the surface. Let's make it 1 in 2. There we go. Didn't do the right side. Right, so you can see there that that batter has been added between that region. I now have a 1 in 2 batter. I didn't notice on the left-hand side, but I've got 1 in 2 there as well. But that variation only happens between 0 and 50. Let's make it 1 in 6 again on the right side. Update the model. Now, one thing to point out, as I'm doing this, making these edits, this model viewer window is updating as well. So you can see that as I'm making changes to my design, this model viewer is fast enough that it updates dynamically. So you can see this big batter here, and you can see it in plan view as well. So very quickly, one thing I wanted to show you to start off with was the maximum offset alignment, which you may not be aware of. The alignment's created in the drawing, but I can say that on the right-hand side, I want the maximum offset, the batter, to be boundary max offset. So if I select and add update to that and rebuild the model, you can see that in the model view it's updated, and in plan it's updated as well. So the batter will no longer extend of that first 50 metres beyond that that polyline, that alignment, which means I'm getting a steeper batter there. Okay, so that's the slope batter. Let's just delete that. Very quickly, let's move on to a fixed width from centerline batter. Very straightforward. All I do is I pick the range. Let's go for the whole length this time, and then I set the width I want out from the center line. So let's go for maybe 10 metres. Once again, constant width means I don't have to fill out the end chainage there. Okay. All right, let's just rebuild that. I can confirm in the cross-section viewer here that with my offsets turned on, that the right batter here is at an offset of 10 metres. Right, but as simple as that to change the batter from a slope batter to a fixed width batter in range. Okay, so let's delete that one. I am trying to move through these fundamental stuff a bit quicker so I can get to the more conditional stuff. Now, the next one I wanted to show you was the dual section batters. So remember, this is the one where, similar to a fixed width, because I define a width, but if the slope to the surface or slope of the batter is outside a range of slopes that I pick, then a second leg will be inserted. So let's have a go at this. I'll insert this one for the whole length. I'll only do it on the right-hand side, and I'll say that I want the width to be 10 metres. But this is where I set the minimum and maximum slopes. So let's go for 10 and 1. I might have that around the wrong way. If that second leg is to be inserted, this is where I specify the slope for that second leg in a cut and a fill situation. So I might just put in at 1 in 2 for now. So on this particular cross section, because we are within, is happy enough to find an answer there for us. But what I might do is open up the vertical gradient. Do it from here as well. And let's just start playing around with the levels, and we'll see when we're outside the slope range, you'll see in the cross-section view down the bottom, the software is adding that second leg in. So it's going up at the maximum, 1 in 1, and then it's forming back up to the surface at a 1 in 2 slope, okay? But when the batter forms within the slopes we want, the minimum maximum slope, then that's good, it'll form. But if we're outside those slopes, then that second leg is formed to match to the surface. Okay, so if you hadn't seen that one before, I just wanted to quickly show you the dual leg batter as well. So let me just delete that. One thing I was going to point out, I did mention at the start, if you didn't want batters didn't want the software to automatically add batters, which sometimes ARD likes to do when you run an AutoModel. What you can do is put in a blank batter entry. So you say, well, from 0 to 1,000, decide to apply both. You leave everything blank, and then the batters will be removed, and the software won't re-add them. So let's just delete that entry. The next thing I wanted to show you, mainly because it popped into tech support the other day, some guys were working on a road and they had a table drain, but they wanted to grade the table drain. They wanted to control the levels of the table drain, but they wanted to put it in conditionally. So if we're in fill, we just batted at surface, but if we're in cut, then the table drain goes in, but it's attached to that string. Now, I've actually set up a variation in here so that this LTD1 code will change offset and levels to a string that I created called table drain. Now, this is on the left-hand side. Now, those conditions I was talking about, the table drain command in here will allow me to put a conditional table drain in, but it won't allow set those codes to string. And I suppose the reason for this is when ARD calculates a road, it's very much calculating things in this order. The first thing that happens is the software applies a template, and then it runs through and it adds the variations, and then it starts calculating the list down here. Batters are actually the last thing that get added to the road. So the table drains routine won't work for us. But I wanted to show you a variation. You may or may not have used it before. It's called conditionally delete sections. So what I want to do is I want to tell the software if LTD1 happens to be in fill, then I want to remove the table drain code. So we just batter back to the surface. So I select on conditionally delete sections. I pick the chainage range which is going to occur. The really tricky thing about this variation is this first option here, which is called code existing to trigger. It does throw people out. In fact, it throws me out sometimes. I forget the purpose of it. But basically, if this code template, then the software will continue calculating. The thing is, this code has to be the last code before the batter, or it's got to be outside the codes that you are deleting. So in this case, I'm going to set the trigger code to LTD2. I want to tell the software that when LTD1 is in fill, delete all codes from LTD1 to LTD2. So what I do is I say deleted code LTD1 as a condition of fill greater than 0. And if that condition is met, I want to delete codes from LTD1 to LTD2. So hopefully what I've done there is right. I won't see things update in that cross section, but let's move across. There we go. So you can see that I'm in a fill situation here. And because of that, the software has removed the table drain codes. But as soon as we're in cut, the table drain gets inserted. So I suppose as I was getting at, the benefit of this is this table drain is actually controlled on a string, right? Controlling the levels, but I'm able to set a condition at which the table drain is inserted based on a code being in cut or fill. So just wanted to show you that one. Only came to mind recently because someone had mentioned it in tech support. So let me just, we can leave that one up. Okay, so the next thing I wanted to get to, close that window down now. The next thing I wanted to get to is intelligent sections. Now, the intelligent sections command is a very powerful tool allows you to set up conditional sections. As I said at the start, you can set up repeated benching for cut and fill areas. You can add retaining walls, gabion or sleeper walls. You can set batters to an alternate surface other than the sampled surface. You can change the batter slope dependent on depth and much more. Can be a command that can seem a little overwhelming when you first open it up, but once someone goes through it with you, you'll find it's not actually that difficult to use. But it is a very powerful command. As I mentioned, the command is basically a revamp of the old multi-section batter tool. So intelligent sections command was written to fill in some of the shortcomings of the multi-section batters command. So multi-section batters is basically obsolete. Now to run the intelligent sections command, I select the bottom part of create edit section, and then down the bottom you'll see the create edit intelligent sections command. Looks sort of like the template editor, I suppose, in a way, in that you get a preview of what's going on. But the idea is that in cut and fill situations, you set up some conditions, and under those conditions, the software will do different things. Apply a batter at a certain slope, apply some benching, etc. So what I might do, rather than creating one from scratch yet, just before, close that window down, just before I created a surface called NS raised. There's nothing exciting about this surface. If I just open up a cross section here, I might just turn it on so we can see it. Surface NS raised, and I'll show it the entire length. All NS raised is another surface that's raised a meter. What I wanted to show you is that I could tell the software for the batters, rather than matching the sampled surface, I want it to match to the NS raised surface. So this is a really simple example of using intelligent sections. Okay. So if I go to the intelligent sections form, I've got one in here called batter to alternate surface. Now on your computer, you might have one called 1 to 3 batter to alternate, which I'm not too sure works too well, but this is one I set up this before. What it does is allows me to set up, and this is one of the great things about intelligent sections, allows me to specify depending on when I'm in a cut situation or when I'm in a fill situation. Now, I was going to go into detail here, but I might come back to it a little bit later. What I might do is go straight to the design data form, and let's just add this intelligent section first, and I'll go back in and show you the mechanics of it later. So to add an intelligent section, you go into the design data form, you add an entry at batters, and you'll see down the bottom you've got intelligent sections. So I pick the change range that I want it to occur, pick what side this batter will be applied to. I'll just go for right for now. And then I select the the intelligent section that I want to add. So I want batter to alternate surface. Now this intelligent section has been set up to link the batter to whatever surface I specify here in surface 1. With intelligent sections, you can set up intelligent sections to reference alignments and strings as well as other surfaces. So if I click Add Update to that, batter is now no longer into the sampled surface, it's matching to that alternate surface. So this is very useful. I mean, you might be working on lot grading, a subdivision design. You've created some gradings for the lots, and you want you want to sample the natural surface, but you want the batter to go to that design surface. This is a perfect example of where this is handy. So let's open up the intelligence sections and just have a little bit of a talk about how this one's been set up. The easiest way to use intelligence sections is to first set up some conditions. And after you've set up the conditions, you tell the software what to do under those conditions. So my first two entries here are these depth checks. And if I open up the first one, it looks like this. I have a depth check from 0 to 1,000. And that depth check happens against surface 1. So if my depth in the design and surface 1 is positive, then we're going to go to batter 1. I have another depth check underneath it. If I edit it, it's saying if my depth between the design and surface 1 is a negative 1,000 to a 0, then I want you to go to batter 2. Okay, so I just added these two depth checks, one for when we're below the surface 1 and one when we're above surface 1. Once you add the checks in, you add a comment in. So all I did was run add comment. And underneath batter 1, I told the software to batter at a negative slope. So if I'm above the surface 1 surface, I want to go down at a negative slope back to surface 1. And if it intercepts surface 1, we've been told to end the batter. The thing with intelligent sections is potentially you could say, well, match to this surface, but then cut a drain in. And I could set up this intelligent section to also include some sort of drain once it hits it. So I could say, look, if you intercept the surface, go to drain, and I might have a comment called drain and some legs that form sections that form a drain. The code that is included is BAT, so same as the batter codes we have at the moment. And similar to batter 1, I've got batter 2. So if we're in a cut situation, then the software will form a 1 in 4 batter up to surface 1. Okay, and then when it intercepts that surface, it ends it. So that's all this intelligent section has been set up to do. And this option down here is being ticked on, so depending on whether we're in cut and fill against the natural surface, the software will still apply the same conditions. So cut and fill is the same. I'll get to that a little bit later when we create a section from scratch. In fact, let's go and create one now. So if I create a new intelligent section, I just hit this button with the green plus, and I don't know what to call this. We'll just call it demo. What I might do is set up. I'll do something very basic. I'll tell the software that depending on certain depths, we'll get the batter to a different slope, and maybe we might add some sort of, I don't want to run out of time, but we might add some sort of drain or second leg in as well. So anyway, when you create an intelligent section, you set up conditions for when you're in a cut situation, and you set up conditions for when you're in a fill situation. So let's start off by adding a depth check, and I will say something like, when I'm at a depth between 0 and half a metre, I want, if we leave this surface blank, it will just compare against the default surface. But I'm going to say when we're at a depth in cut between 0 and half a metre, I'm going to tell the software to go to batter 1. And I'll add another depth check in, and I'll say if we are greater than half a metre, let's go to batter 2. Right, so we've got two depth checks in, one between 0 and 0.5 and the other one between 0.5 and 1,000 metres. Batter 2. So once I've set up the checks, I then add a comment in and then tell the software what to do. So the first comment I named batter 1. This is when I'm between 0 and 0.5 of cut. And in this situation, or in order to form the section, I've got a few options here. This is where these data items come into play. If I wanted to add a batter, I'd just go to tell the software to add a batter to the surface. If I wanted to start adding some benching, so if I'm in a lot of cut and wanted to find the surface by benching up, I could use this benching option. If I just wanted to put in a section at a width and the slope, similar to how you create a road cross-section template, then I could add a width by slope section. I could put a width to a surface in and nominate that surface. There might be another surface in the drawing. And I could use a width to string. So I might have a string in the drawing, and I might want the software to reference, when it adds your section in, reference the levels of the string. So you sort of see what this sort of opens up for you. You can do some quite interesting things using this particular command. But anyway, I'm going to keep it simple and say that batter 1 is just going to batter to the surface, and we'll say at a 1 in 4, it'll go to the surface. And if it intercepts that surface, then we'll end the batter, and that section will be added with the bat code. Right, if we're getting deep, between anything greater than ½ a metre, then I'm going to add another batter. Oops, no, sorry, got to go to add a comment. So this is set up for batter 2. And in this case, I'm going to batter at, go up a bit steeper, maybe 1 to 2. And if we find the surface and the batter, and we'll call that code bat. Now on the right-hand side is the preview, and I can change the cut depth. So you can see I'm currently at a, is that right? Have I done something wrong? What did I do wrong? I've done something wrong. So yes, test surface, correct. Test surface 0.5 to 1,000. Batter 1. Right, but if we're greater than that, I don't know what I've done there. It seems to be working. Just I don't know. I won't stuff around too much with it. But anyway, depending on, this is meant to be a preview on the side. You can see there's the one in 4 batter. And one nice thing over the old multi-section batters command is when you select on an entry here, it lists, highlights in the list what is actually causing that section to be added, right? So if I go into a bit more depth and we go to the 1 in 2 batter, and I select on, you can see it's that entry. Look, what I could do very quickly, on batter 2, I could say something like, well, I want this section to form to the surface, maybe 0.5 below the surface, and then go to the next line. And then you can see here that that code is just finish up ½ a metre below the surface. And then I could, because I said go to next line, I could add another batter in. So I could say batter at, say 1 to 4 and if you intercept the surface and the batter, I'll call it bat1. All right. This is sort of similar to that dual section one that I set up, I suppose. Other than doing depth checks, you can do slope checks as well in this intelligent sections command. But anyway, if we're not that deep, we go at 1 to 4. If we start getting deep, then the software will put in a 1 to 2 batter, and then 1 to 4 when it gets to within half a metre. So anyway, on intelligent sections, feel free to send me an email. I can give you some more information on this command. Very useful command for doing, intelligent type batters or sections. So I might just finish this intelligent sections by applying it to the road. So I just called it demo. I wasn't referencing any surfaces for this one, and I'll put it on both roads. Okay, so let's open up the vertical grading editor here. Right, but as I move the levels, you can see if I'm within the half a metre, it goes back to the surface at 1 in 4. But as we get deeper, it puts in those dual legs going up at 1 to 2 and then 1 to 4 to the surface, okay? So you do all sorts of stuff. Now, no batter's been put in fill because I actually didn't tell what happens in a fill situation. I only set this up for cut. I did mention as well that this is great for retaining walls, and just to very quickly show you, we do have a retaining wall in here. All right, and you'll see as I'm moving the levels, that retaining wall is being put in. Just on the model viewer note, I actually set this up with a material. So there's that wall here, and you'll see that as I move the levels up in the profile view, my render just updates. This will give you a bit of an idea of how quick this new model viewer is. It's great to be able to check your design in a 3D environment so quickly, as opposed to just looking at line work in the drawing. Okay, so moving on, let's just close those down. I'm just going to open up another job. And just before I started this web session, I created an intersection and I've added some batters to the roads, and I forcefully put in this batter overlap issue. So I'm sure it's something that all of you have come across before, and if you are outputting it, then the software will open up this annoying message box telling you that there are batter overlaps that have been found, and it draws all these circles and lines in the drawing. All right, so if I hit on AutoModel here, this is the message box that I'm talking about. It says review boundaries, design offsets, extend past arc centers, and if I click OK, I get all these circles and lines in the drawing. So as I was saying at the start, the software loves the batter codes because it uses the batter codes to form boundaries. And if those batter codes if they don't exist, or if they loop back onto each other, then the software is unable to find those, unable to form those boundaries. And if you're working on a subdivision or a particular job and you don't have the boundaries put on by the software, it can look a bit ugly. You've got all these triangles running all over the place. So I just wanted to talk about the things that you can do to resolve those issues. Although these error messages appear, the software does actually try to fix the issue up for you. I suppose for me, the annoying, and for the users as well, is the annoying thing is that message box keeps and they're reporting stuff in there. But if I was to say open up the model viewer and to have a look at this job in 3D, you'll see that the batters actually look pretty good. The software or despite the error message popping up, the software's sort of found a way to resolve the batter here in this case. But look, if I was to open up the vertical grading editor and make a change to the design, every time I do so I get this form. It's quite annoying. So anyway, let's talk about ways to fix that up. So I'm just going to go select similar delete. So this is our issue, this is our loop that I want to fix up. A couple of ways to fix it up. I suppose one way is I just changed the batter slope. Now, in order for me to cause that loop, I added a batter at a 1/8 slope, right? So we could change the batters up, tighten them up a little bit, and then the software won't cause those loops. That's one way of doing it. In fact, you probably notice when we automate curve returns, we always add batters in on the curve returns at a 1:1 slope to try and avoid these types of to do this, you will need the latest. We should have the latest version of ARD. What I can do is, using Model Builder, I can create a model builder model that's linked to AutoModel, and I can do this using the Open Automatic Road Model command. Now, you may or may not know that in the last release of ARD, we actually fixed a lot of stuff up here. So beforehand, previously, this was a one-pass thing. So if I ran this command and then I went and changed the raise of the curve return, my model builder model wouldn't update with the required edits, trimming edits. But now, in the latest version of the software, this is the one that's available now, this model builder model is linked to your auto model. So if you make changes to the curve returns or whatever, the model builder model updates. It's one of my favorite things we put in the software in the last release. So anyway, I'm going to open up Road. I'll create a new model builder model from the automated one, and I'm going to call this one so if I select on build on this, I actually have set my surfaces up, because I'm running the Civil 3D version, I've set my surfaces up so every time I create a surface, it gets outputted as a Civil 3D surface. And if you didn't know you could do that, if you go into the active drawing settings and click on the modeling tab, all you need to do is click on build all surfaces as the 3D surfaces. And if the software can create a boundary, it'll add it in here for you. So I will trim up this batter overlap in a sec, but I just wanted to show you something. Now, whenever you create a model builder model, toggle display form appears. I'm going to tell the software that whenever there's a design change, I don't want total model to auto rebuild in the background, okay? But I want the final surface to automatically rebuild. Right, let's just turn the contours on for that. So beforehand, with this issue, when I was making changes to AutoModel, that annoying error message was popping up. But hopefully now, if I go and move an IP, that error message is no longer appearing. Now, what I should do, I actually probably should have told the software to not add those boundaries in for me. But what I've done is I've suppressed those annoying error messages that were popping up before when AutoModel updates, okay? However, I don't have a boundary on this surface. Model Builder doesn't have an automated boundary at the moment, but I've never found that as a big issue because, you know, I can just draw my own in. You know, we all know how to create a boundary, but I just draw a polyline around the surface. Okay, and then I can add that in as a destructive break line, which means any triangle that it passes through, it removes that triangle out. And you might have done this before with Civil 3D surfaces. If that surface rebuilds, you might find that your boundary gets lost. And the reason for that, if I jump into the surface properties here under definition, what happens is when the software recalculates, it adds the break lines down the bottom. So the boundary is up the top of the operation, but there's nothing to create a boundary against. So if we do rebuild the model, you just need to make sure that the boundary gets put down the bottom, so it's got something to add a boundary against. Now, one thing very quickly, just opening up that model builder model again. My model actually looks good there. But look, one thing that I could do to sort out some batter overlap issues, in fact, what I might do is I'll just create another model for this. Let's just turn total model back on for a sec. I'll just go back into it. But look, one other thing you could do in order to resolve batters is to override trim out the batter over certain regions. So my loop issue is gone because the software sort of fixed it for me. But if the loop issue was still there, a nice quick way to fix it up as part of the model is to use Model Builder to do it, because what I could potentially do, what I could do if I wanted to, is I could tell the software to remove the batter code over a certain region. So I could say, look, from the start to about this point, exclude the batter. And then that is a way of sort of getting rid of that loop through that area there. So I suppose to recap on resolving these batter overlap issues, the first thing is that annoying message box that appears, and I suppose my answer to that is, hey, create a model builder model using automatic road model. It could just be basically a copy of the auto model. But as you're making changes to the software, that message box won't appear. You could also use Model Builder to trim out those overlaps. So as I said, you could exclude the batter between a certain region as well. Or the third option is you change your design to ensure that no overlaps occur, whether changing the slope or fixing up the geometry of the project. Okay, so look, they were the things that I wanted to run through. So starting off at sort of the fundamentals of batters, but I did want to show you some of the conditional options you've got. Certainly, if you haven't used intelligent sections before, I recommend that you have a look at it. Even if you just want to change the batter based on slope or based on depth, or set the batter to an alternate surface, is very handy just for those examples, but you can do some really complex stuff with it as well, more advanced stuff with it as well. There is a video on YouTube that it goes through a quick demo of intelligent sections. That's on our YouTube page. You'll find it on our blog as well. Thank you for watching this webcast. I hope you have picked up a few things along the way. And look, if you are interested in attending one of our roadshow events around Australia, then please visit advancedroaddesign.com.au to book your seat. I'm going to open up now for some questions. Throughout the session, I didn't get any, so if you want to ask a question, now's your opportunity. Okay, it doesn't look like we've got any questions. Look, I'll stay on for a few more minutes, so if you do have any questions you want to ask, then feel free to. If not, you can always send me an email, andrew.banson@civils. You could put a support ticket in as well if you like. As I said, if you wanted a copy of the recording, you can email myself or feedback@civilsurveysolutions.com.au. Okay, look, I hope everyone enjoys their weekend, and thank you all once again for